Hello students, this is the video lecture covering section 10.4, Perimeters and Areas of Similar Figures. Our learning goal for this lesson is to be able to find the perimeters and areas of similar figures. So let's get started. The theorem for this section says that if the scale factor of two similar figures is a to b, then the ratio of their perimeters is a to b, and the ratio of their areas is a squared to b squared. So we have two trapezoids that are similar, and we're asked what's the ratio, smaller to larger, of the perimeters. So in this case, there's only one measure given. We have the top of one trapezoid and the top of the second. So since this is length, we're single dimension. Perimeter is also single dimension. So we can see that the ratio is 6:9. Now area, on the other hand, is two-dimensional. It has both length and width. And so that's why we square the two. So we start with the ratio of the perimeters, but then we square each number. So we have 6 squared to 9 squared. So we have 6 squared, which is 36. And we're going to compare that to 9 squared, which is 81. As is always the case, we'd like to reduce this. So 36 to 81 reduces to 4 to 9. So again, perimeter, single dimensional. So we just write them in ratio. With area, we have multi-dimensional. So we take 6 squared to 9 squared. So finding areas using similar figures, we're given that the scale factor of them is 3 to 4. So we're told the scale factor is in ratio 3 to 4. So we know that if we're looking for area, we need to consider 3 squared to 4 squared. Three squared is 9. Comparing that to 4 squared, which is 16. And so this is the ratio of the areas. So we can solve this by using a proportion. We know that 9 is to x as 16 is to its area 96. So again, we're trying to find the area of the smaller parallelogram x. So we're comparing 9 to the smaller one, and that is the same as 16 to the larger one. So cross multiplication here, we get 16 times x equals 9 times 96. Divide both sides here by 16. And we get that the value of x equals 54 square inches. Okay, so our next question is a word problem. It says, during the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables. Next summer, the city will let them use a larger, similar plot of land. However, in the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can the students expect to harvest next year? So the shape of this land is really not relevant. So let's just assume for just a second that this land is a square. So we don't know what the dimensions are, but we can say that this square it might as well be x times x. So we know that x times x, or x squared, was equal to 13 bushels. Now next summer they're going to get a bigger plot of land, which is 2.5 times the original. So each dimension now is 2.5 times x. So just like in the original we had x times x, well now we have 2.5 times x squared, and we're trying to figure out what that's going to yield. 2.5 times 2.5 is 6.25 times x squared. So we can see that the difference here between this year and the previous year is multiplication by 6.25. Last year they had 1 times x squared, but this year they have 6.25 times x squared. So to find the final answer, we're going to take the 13 and multiply that by 6.25. And here we find that the students will be able to harvest 81.25 bushels the following year. A huge jump from 13. So this is the kind of question that a lot of students miss. It says that the scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. How much should the larger piece cost? So oftentimes I see people mistakenly set this up as a proportion. They say 3 to 5 is going to equal $2.50 compared to some other value, and they cross multiply here and solve. The problem is glass is not usually priced based on its linear dimensions. Glass is usually priced based on its area. So the true proportion that we want to set up is 3 squared over 5 squared is equal to $2.50 over some value x. So here, cross multiplication gives us 3 squared times x is going to equal 5 squared times $2.50. So dividing both sides of this by 3 squared, we can eliminate this 3 squared here. And solving this on our calculator, we get that the larger piece of window will cost about $6.94. These questions can be somewhat confusing. The advice that I would give you is to check to see what they're actually pricing. Would it be priced based on length or area? And then make your decision on how to set up the proportion. And so here we have our final question. Finding perimeter ratios. So we're told here that these two triangles are similar. So we know that their areas are in ratio, but in a very special way. So the first thing that I would do is I would set this up as a ratio. 50 over 98. And I would try to simplify this if possible. We can see both of these are immediately divisible by 2. So we end up reducing this fraction to 25 over 49. Now here we're in area land. We want to get out of area land and get back into scale factor land. We have to take the square root of both of these. So we take the square root of 25 and we get that this is 5. And we take the square root of 49 and we get that this is 7. So once we've gone from area into scale factor land, we find that this is a ratio of 5 to 7. And if we remember back to that theorem that we stated at the very beginning, if the scale factor is 5 to 7, then the ratio of these two triangles' perimeters is also 5 to 7. And so that concludes section 10.4, perimeters and areas of similar figures. Thanks for your attention, and I'll see you soon.